Good afternoon. Welcome, everybody. Hi. So my name is Dan Murphy, and I write code at the Financial Times. Out of interest, how many other coders are in the room? Developers? Wow. That's quite amazing, isn't it? So lots of technical people. Great. OK, so I'm going to talk a little bit about code, and I'm also going to talk about some of the things that we did which were not code-related, because today I'm going to tell you a bit of a story about a project that was failing. Despite the hard work that everyone had put into it, this project really wasn't delivering as well as we wanted it to, and it was at risk. It was at risk of failing to deliver, and that would have been quite catastrophic for us, because this project forms an important part of the FT's digital future. So I've been in IT quite a long time. As you can see, I've got a grey stripe, thanks to the amount of time I've been working in it. And I'm sure there's other people in the room who've been in projects that are failing. And sometimes there's this tendency that we kind of soldier on and battle against these projects and try and make them work. And yet sometimes they don't still work. And so what we did for us with this project was that we took a hard look at what we were trying to do, looking at the technologies that we were using, and we decided to change. Normally, when we change things in IT, we change just one thing at a time, because then you know what you've broken, what you haven't broken. We thought we'd ignore that. We ignored that, and we changed more than one thing at a time, and I'll come on to tell you how that worked for us a bit later. So what we did was we deliberately decided to chuck away over a year's worth of work. And we rewrote that using different technology, using a different programming language, and we rewrote that in just about 3 months. So that's quite a dramatic piece of rework that we did. And in doing so, we changed the project from one that was faltering and failing to one that was successful in delivering. And we also changed some of the cultural aspects of how things are done at the FT. So today I'm going to talk to you about the story of our change, the decisions that we made, and how we learned to embrace and empower ourselves to make these changes. So for those of you who might not know the Financial Times, being in London and being where we are, I think most of you probably know, but it's actually quite an old newspaper. It was launched in 1888, and then it actually changed its name to the Financial Times a bit later on that year. A few years later, about 5 years later, it actually decided to print itself on pink paper, and it's been printing on pink paper ever since. Times has been publishing for many, many years, and around 2010, a change was being seen in how our content was being consumed. Until 2010, in fact, even in 2010, majority of the readers of the Financial Times were doing it through paper subscriptions. A few years earlier, the Financial Times had released a sort of a free paywall, so you could read certain articles without having to pay for it. And also then it released a HTML5 web app in 2012. And this combination of these things saw that in 2012, we actually started seeing the transition from a revenue based on paper subscriptions to one based on digital subscriptions. And that story has continued. So we now make more revenue from our digital subscriptions than we do from our paper ones. So that means that with digital subscriptions, more things are possible. So you can see in this here we have some nice sort of interactive graphics that we display. We have videos and podcasts and all the multimedia things you'd expect to see on a modern website. And that means that we have to deal with our content in a different way than we used to. So these pages here are taken from the current website, which is the one that we're kind of moving away from. And one of the reasons we're moving away from it is that the solution that was built was a monolith. And that caused some difficulties because it meant when we wanted to build APIs to enable other products to be built on top of it, we were kind of quite tightly coupled to the way the monolith had been written. Also, some other aspects of it, for example, there was a lot of heavy XML in it. So really, the current website and the platform that sat underneath it wasn't fit for what we saw as going forwards in the future. So things had to change. So about 18 months or so ago, a band of fearless developers decided to set off on a little journey. And the journey they decided to set off on was to build a semantic linked data platform. Because if you want to start doing things like linking concepts and content to other information that you know, like organizations and who's members of boards and all this kind of important data to provide a really rich experience, then the obvious way to do that was using a semantic linked data platform. It seemed like it would be a great idea at the time, so off they went. They headed off towards the peak of semantics, and sadly not everyone made it to the end of the journey. So this is me 18 months ago. I'm a little bit different as well. If you need a hint, I've got the same glasses, but a few other things have changed. And in fact, 18 months ago was just before the birth of my second son, and at the time I wasn't working at the Financial Times, so I wasn't involved in the beginning of this project. I was actually a freelance developer and also a part-time voluntary counsellor. And one thing I noticed as a qualified counsellor is that when we look at change is kind of inevitable, it's out there, it's always happening, but we kind of see it as out there rather than something that we can take control of ourselves. And I think that seeing as external to us, change, is the thing that kind of disempowers people, and also is probably one of the biggest reasons why people end up in therapy, because they're coming to terms with some kind of change, or they're trying to effect a change on themselves. So if I fast forward now to about sort of autumn time last year, I was looking for a new job. And so I happened to come across this job on Stack Overflow. I was a freelance developer at the time, but I thought, oh, why not? I'll have a change, try something different, because they were looking for a permanent person. I'd happened to work, do a contract with Pearson before, and so through that I'd met some people at the Financial Times, and I knew that generally they were nice people to work with. They had some really great developers, looked like a nice building, fun environment, so I thought, well, why not find out about it? Because they were building this really interesting thing called a semantic linked data platform, and I thought, oh, that'd be great to be involved in that. And they're doing it in Java, which was something I've been programming for an awful long time. So in the end, I joined the team last October. Now, not long after I arrived there, it was quite apparent that the project had reached a bit of a decision point. As I said when I started, the project wasn't really delivering, and people were being concerned about this non-delivery and what can we do about it. Some of the problems we had were around the amount of time it was taking us to load data into the platform, and some problems with the actual underlying technology that we were using as well. So we were thinking, well, what can we do about this? How can we actually turn this project around? And we had a look at what we had decided to take with us on this journey. It looked fantastic, nice comfortable chairs, nice big sort of a set of tools that we could carry along with us. But actually when you started looking at all the equipment and all the stuff that we were trying to take with us to build this semantic platform, it was that was slowing us down. To give an example of it, the modeling was typically done by some people associated with the project but not directly inside the project. So the modeling of things done in OWL, has anyone done any OWL modeling, semantic modeling? So there's a few nods. Oh yeah, a few hands as well. Yeah, it's kind of interesting. It's a bit of an art, and it's probably a specialist art, shall we say. It's not something that your average developer particularly wants to get involved in, and it's something that takes a while to learn how to do correctly. I'm sure you can do perfect models this way, but it's not the friendliest of things to do. So we had a look at what we were trying to do, what the business was asking us to do. And what the business was asking us to do was not to build a linked data platform. It was asking us to provide a way to link our content with other things that we knew. So we would take the articles in, we'd process them, we'd extract concepts from it, and then we'd annotate these articles with the concepts and then be able to link them all together to make a kind of a linked set of articles with all these different concepts. And although typically you could do that with a linked data platform, it's actually simply a graph is what we're trying to build. So the project wasn't doing very well, and we were realizing that some of the choices we'd made were not really helping us. But it wasn't all bad, because the architecture that we had chosen wasn't to build a monolith. We decided to build a set of discrete components, building blocks, microservices, call them what you like. And the nice thing about this approach is that it means you can swap one thing out for another thing. So you could write a microservice, and as long as you write them well, then you should be able to replace that with another microservice in any way that you want. That's the joy of microservices, that they're independent units that you can swap in and out without affecting other parts of the system. And since we'd taken that as an architectural approach, it meant that we could choose to do things differently quite easily without having to rewrite this whole monolith system again. So we decided we really wanted to get stuck into this. And what we did was we took ourselves away from the main office, and we locked ourselves in a room for a week. Well, kind of left ourselves out in the evening, but during the day we sat in this room, and what we did was we decided we would try out different combinations of things, see which things worked for us, see which things didn't work, and what kind of problems they fixed, and how it felt and tasted to do things with these different technologies. So we kind of cleared the table and put down what we were using. We were using an RDF store and Java to build our platform with. And obviously we could choose a different RDF platform, a different tripple store, so that was one of the things we decided to change, to see whether it was simply a problem with the product that we had chosen or whether it was something else. But we thought, well, we're doing microservices, and let's see if we can do something a little bit more different. So we also decided we would try using Java with Neo4j, a graph database, and also Go with a graph database. Because we had a bit of a Go fanatic who was in the department, not associated in our team, but he really loves Go. And he convinced us it would be a good idea to try it. Now, none of us had really actually tried Go before. In fact, none of us had really had any experience with using Neo4j. But during that week, we tried out writing code and tried out different triple stores and also graph databases, and kind of see what fitted for us, what worked well. What worked well for us, surprisingly enough since I'm here, was Neo4j and Go. One of the things we liked about Go was we found ourselves writing an awful lot less code than we had to do when we were doing Java stuff. In my slightly older history, I was going to say ancient, but I'm not quite that old, I used to work for IBM, and so I came from a background of writing lots of Java, and over the years I've noticed how much Java you write to do anything. And one of the nice things about Go we found was that it was actually not too difficult to understand, and you could get something working quite well. And we liked Neo4j, so we decided to use those, because we've seen how quickly we managed to do things. In fact, what we ended up choosing probably really is the Neoism Go library. Does anyone use Neoism? No? Ooh, okay. So basically, it's a driver for talking to Neo4j. It's actually quite similar to the driver that they were showing with the Bolt thing in many ways, and I'll show you a bit of code in a moment. One of the experiences we had when we were writing Java to Neo4j was that question that was put up. Should we use the JDBC driver? Should we use some other library? Or should we use the REST interface directly? We tried JDBC, we tried REST. We found we had a few problems with them both in terms of the amount of code we wrote, and also some of the limitations of the drivers as well. I understand the Spring Neo4j project is fantastic. Spring Neo4j data, anyone use that? No? Oh, one person. Okay, expected more people than that. But we don't use Spring at the Financial Times in this project, so that kind of wasn't on the cards. So we then, after this week, we spent some time kind of honing our skills, practicing our techniques, and actually trying to take what was kind of prototype proof of concept work, which we developed in this week, and put it into production. Because things we hadn't done during that week was things like write extensive test cases, or figure out how we're going to deploy this in the cloud, how we're going to make it resilient, how we're going to do things like centralized logging and all that kind of stuff. So the week told us that we could probably do things. It de-risked an awful lot of things for us, and we then went on to actually come up with some practices. And I'm going to take a few minutes to share a few of those practices with you. So this is a very simple node in our graph. It represents a company. It represents Apple in this particular case. And what you can see on it is that we use different labels because everything in our graph database is a thing. Some things are also concepts. And obviously, Apple is an organization, a company, a public company. So that's kind of actually inherited from our semantic model in a way, that kind of set of properties, of labels, sorry. And then we have some properties of it. We have our own UUID. It happens we use a proper UUID, right, not just a numeric number. But actually, our data inside the graph database isn't the sole source of our information. We also have data coming from other systems. One of those systems is called TME. And so what we started off doing was putting these other systems or other identifiers as simple properties in our graph. And then we looked at it and thought, well, actually, that kind of gets a bit confusing because you end up polluting the root of the object in the graph. So actually, let's iterate a little bit. And one of the things we liked about Neo4j was the ability we had to iterate through our models. So the next thing we tried was, well, let's group them under this thing called identifiers. So we've got identifiers to other systems or other types of identifiers for our UUID. I can use a laser, can't I now? Yeah. If we have other types of identifiers, then we can kind of put them in as a set of properties. Seemed like a good idea at the time. Actually turns out to be a very bad idea because of the way indexing and searching works. You can't actually make much use of it. Because what we wanted to be able to do was to be able to concord between the identifiers that we knew and the identifiers that other systems knew about. And you can't do those kind of queries with that kind of structure. We'd kind of been reluctant, but when we tried this approach, it was great because it solved our problems. We actually added new nodes into our graph. And there's a few nodding people, so I think there's a few people who have been down this route as well. Although these aren't real entities, really, in a sense, they actually kind of make sense to put them out as separate things in the graph and then to build a relationship between these other types of identifiers and our representation of it. The other thing that's quite nice is we use these labels so that we can quickly say, well, give me all of the LEI identifiers, LEI standing for legal entity identifier, or we can say, well, give us all the TME identifiers, and that means that we can kind of concord, so we can come in and say, one system knows about Apple as this code, and then it can actually resolve it to what we know, and then what's not shown on this diagram is obviously we then have relationships to subsidiaries, to people who have memberships with the organization, to articles, and all that kind of stuff. So we can link up information about companies and organizations with all the other stuff that we know, like our articles or podcasts or whatever, our content. So since no one said they were using Neoism, I'm guessing there's not a lot of people using Go here. One. Excellent. Oh, so, okay, interesting. Not using Neoism, but using Go. So this is a representation in Go of a structure, or two structures technically. There's a thing structure, which is our base representation, and then we happen to store information about brands inside of our database as well, inside of our graph database. And so the brand is a composite structure which embeds this thing structure into it and then has some extra properties. And we use a similar pattern other places as well. It's just, being dry, really. And over here is how it's then serialized on the wire. So this is effectively the public interface that we use for our APIs for when we're serializing our data out. What we did through experimentation was try and figure out an efficient way of getting it out of the graph database and into that structure so we can send it out. And what we came up with is Neoism. So you saw in one of the keynotes how you get a driver connection and you run a query. It's similar in Neoism. And what we do is rather than read out our nodes, because that's not very performant, and there's other reasons for it, we actually construct a structure which maps directly into our brand structure so that our results read straight into the structure, which we then serialize. So we save ourselves the effort of having to go through some kind of DTO pattern or something like that, where we're copying between two different objects. So again, we saved the amount of code we could write. It makes it a bit more fun to write your queries because you have to kind of work out your structures for it. Another thing to point out is that we have a hierarchy of types. And there's a little function in here kind of hidden away, which is labels. So public company, organization, all that kind of stuff gets turned by this labels function into an array of strings, which we then send out. With Neoism, if we hadn't done that and we'd got back nodes, to retrieve the labels for a node, we'd have to make another call to the database. So in order to make it more performant, we saved ourselves here 3 extra calls for each call of the API. So if we hadn't done that, it would have been 4 queries to run instead of 1. So we get a nice performant thing and we write less code. But that's not to say it was all easy. We did have a few problems. We had rough waters to navigate. And a couple of things that we found was we actually found a bug in Neo4j, which is not bad for a couple of months' work. It's been fixed now, which is great, but we only detected that bug because we had someone who really knew our data. Because what happened was the query would run, be no error statement whatsoever, but we'd get duplicate bits of data back. And so one of the things that's challenging, I think, about writing any of these kind of database data access systems is when you're testing it, is to understand what results you should get back, not just does it crash, does it give you an error, but kind of actually validating your data, the integrity of the data and the results you're getting back. As I said, we tried Java and JDBC and found that didn't work for us for various reasons. Just writing volumes of code, also the JDBC driver didn't seem to like the way that we wanted to model things to do with UUIDs and identifiers. And one of the things that I think's kind of quite lacking in the land of Neo is date and time support. A few nodding heads. It would be lovely to see that, wouldn't it? Because everyone seems to write things as either an integer or some kind of long int, or build a date tree and then be able to do before and after kind of stuff. Why can't we have it as a first-class language? It would be lovely. First-class thing. Sadly, not in version 3 as far as I can see. We love the user interface, performance, we've talked about that. So just really in conclusion, we've come a long way over this 3 months. We've chucked away 12 months worth of code, rewritten over 15 microservices and written some new APIs and microservices along that process. And we're only a small team. I think we're about 4 developers now at the moment, maybe even less. It's kind of a slightly flexible number, which is kind of like more than one thing a week to produce we've been doing, which is pretty good. And that includes deploying stuff into the cloud resiliently and also doing a first deployment to containers. So we're doing an awful lot of work in that time. And I think we are all unanimously agreed that if we'd not taken that risk and gone for Neo4j, in fact, a combination of Neo4j and Go, then we'd probably be still writing the stuff now. So that combination really worked for us because we were prepared to take a calculated risk to chuck stuff away. So perhaps if you're kind of setting out on a venture or looking at a project that's kind of faltering, then I'd like to encourage you to take a look and see how radical you can be, how much change you want to take and take control of, because we found it worked for us, and as a team we feel more empowered and more in control of our world now. So thank you very much.